So this is on multiplying polynomials. So we were just talking about polynomials, and we did addition, and we did subtraction. We are going to do multiplication. We are not going to do division of polynomials in this class. We will do it next semester for those of you who are taking college algebra. But for this class, we're not going to worry about that. We're going to stick to multiplication.
I'm already worried.
Don't.
She actually is smart, but no. She always thinks that's Hallie.
All right.
All right.
So this first one, this is something we've already done. This is review. So this is nothing new right now, so don't get psyched out. You did this for your homework. I think it was section 5.1. So when we're doing something like this, how do we multiply this number times this number? What do we have to do? Let's see how much you remember. Hopefully something.
So you multiply the 4 times 2.
You multiply the numbers. Yep. So 4 times 2 gives you 8.
3 plus 2.
Yep. And you multiply the x cubed times the x squared, and that gives you x to the 5th power because you add the exponents.
And y.
And then you have the y. So y and y. Y to the 4th and y to the 6th. That will give you y to the 10th. And then finally z.
C to the 4th. Well,
C to the 4th. So that's, you've done that already, right?
Mhm.
No big deal. You just have to remember that those parentheses just means times. And so we're just multiplying all these different things together. You group them by their variable. So nothing new there. Everybody okay with that as some review? Okay. So let's move on to the next one. And notice you can view these as polynomials, but how many terms are inside this parenthesis? Now be careful when you answer this question. How many terms are inside this parenthesis?
well, 3.
1.
Because none of them
Oh,
have a plus
no.
or a minus.
Because notice there's no pluses or minuses in here. So that is all one term. How many terms are inside of this one? 1. And that's what you've done so far. It's just one at a time. We haven't gotten into the multiple terms. That's what we're going to get to now. Okay? So notice what happens now. We're taking a monomial, one term, times a, what is this one? A trinomial, 3 terms. Okay? And to do this, if you remember, we've used our distributive property when we would distribute, when we did equations and stuff. That's what we're going to do. We are going to distribute, and this 4x cubed will distribute to each thing inside the parentheses. Okay, and I think we've done this before already too. So this one is not really new, but we're thinking about it in a little bit different way, thinking about it as polynomials. So when we multiply this times this, we do the exact same thing we just did with that last problem. We multiply the numbers together first, and we get what? 20. And then we multiply the x cubed times the x squared, and we get x to what power?
6.
Nope.
5.
5. Because remember, you got 3 x's and then 2 more, so a total of 5.
So what's the difference between whenever you do?
The multiplication and the addition.
Well, you know how on the past one we only did it by like terms, like and then now we're actually combining.
Okay, that is a great question. So does everybody understand what you just asked? What's the difference? How come we can I'm guessing, okay, I'm going to alter your question, but I think you're,
yeah.
how come we can multiply this 4x cubed by the 5x squared? Because they're not like terms.
Yeah, that's what I
Right?
meant to say.
And here's the reason. Because you're multiplying.
Okay.
Before we were adding or subtracting. Adding or subtracting, you can only use like terms. But with multiplication, you can just multiply. Okay? You remember, I know I don't like to say this word because everybody freaks out, but you remember when we did fractions?
Yeah.
And you could only add or subtract fractions if you had a common denominator.
Yeah.
But with multiplying, you just multiply straight across. It's really easy. Okay? It's kind of the same thing here. In adding or subtracting, there's these special rules. You have to limit yourself to only like terms. But here we can just multiply. Okay? So we've done the first part. Does that answer your question? Okay? So we've done the first one, 4 times 5 and x cubed times x squared. Now we do this one, and we again are multiplying. So 4 times a negative 2 gives us negative 8. And then x cubed times x is
X to the 4th.
x to the 4th. Very good. And then we distribute to this one, and we get what?
20.
Plus 20
X.
x cubed. And again, when we write our answers, try to write it in order from biggest exponent to smallest exponent. I don't know if the computer will count you wrong for that, but that's what we call standard form. We call it descending order, but from the biggest one to the smallest one. The exponents 5, 4, 3. Does that make sense? Okay, and we did that on all the adding ones also. You may not have noticed it, but I was just doing it automatically. But that's why we do it. We always write the biggest power first and then go down to the smallest.
So if it was bigger, we switch it.
We just rearrange it. Because remember, here's our term. 20x to the 5th is one term. Negative 8x to the 4th is another term. And the signs go with what's after that. So if we move them, the signs just move with the numbers. Okay. So does that make sense how we distribute? And we, like I said, we've actually done that, but I think we just had a number on the outside that we would distribute. But now we have a number with a variable. So any questions before we go on? All right. So we've got another one that's very similar to that. But again, we've got monomial on the outside, and this time, what do we call the inside?
No.
Binomial. You're close. Binomial. Okay. So we take this term times this term. And what will we get when we multiply those?
6.
6. Now we deal with the a's and the b's separate.
Four.
So a to the
4.
4th and b to the 3rd. Does that make sense?
Yeah.
Because what's automatically by this b right here? A 1, and by this a is a 1. Right? So you deal with each letter individually. And then we multiply times this one. And what will we get there?
8.
And it'll be minus 8. And then what?
A to the 4th.
A to the 4th.
And just b.
And we still have the b. Okay. Now this one, when you've got multiple letters, we don't worry as much about which one goes first and second. You just kind of write it down. Okay. Does that make sense? Are we okay to go on? Any questions? All right. Okay, now we're getting to where we're going.
And we wouldn't have to simplify it more.
You can't, because now you're subtracting and there's no like terms. Does that make sense?
Oh, okay, because those two go together. Okay.
Yep. Okay, so now what do we have here? Describe this for me. The first one is a binomial, and the second one is a binomial. So this is new, right? This is the new stuff for really the new stuff for tonight with this lesson. Okay, so here's how we multiply binomials. We still use the distributive property, but we have to do it a little bit differently. So, and I'm going to use arrows to show you how we do it. Remember how I was using arrows in the last ones? So here's how we do it. This 4x distributes to the two things in the other parentheses. So one at a time, but I drew both arrows just so you'd see it right away. So we're going to multiply 4x times 3x. And what does that give us?
18. 12.
12?
Yeah.
And how about the x's?
12.
12x squared. X to the first and x to the first, right? So x squared, x times x.
Mm-hmm.
Okay. Then 4x times the negative 2y. What does that give us?
8.
Negative 8. X and y. There's just one of each, right?
Mm.
Okay. So we've taken care of the 4x. What do you think we might do with the 7y?
Distribute.
We're going to distribute that also. So the two things from the front distribute to the two in the back. So 7y times the 3x gives us what?
21.
21. And what else?
YX.
Okay. Yx. And then here, minus
14.
14 y
To the second.
squared. Okay. Now, there's something here that we want to think about. Notice now we've got 4 different terms, correct?
Mhm.
Obviously this one's x squared, there's nothing that matches up with this. And obviously this one is y squared, there's nothing that matches up with that. But in the middle, right here, I'm going to tell you that these are like terms. Why?
Because they're both an X and a Y.
They both have x and y, and remember, when you're multiplying in that term, the order doesn't matter. So writing this, and usually we write it in alphabetical order if you probably were looking at some of your homework and that's the way you typically do it. This is really the way we would normally write it, 21xy. So once you write it like that, it's like, oh yeah, that's a like term. Does that make sense? So you're not going to change what's there, but the order can be switched without causing any problems. So we're going to write down our 12x squared. What do we get when we combine these 2 like terms?
Negative 13x1.
Not negative. 'Cause you-
Oh, positive.
positive 13 xy. Right? The like term part is the xy. That has to be exactly the same. And then we just write down the minus 14y squared. Okay? So a lot of times when we multiply a binomial by another binomial, not every time, but a lot of times, we will get a trinomial when we're done. Because a lot of times that middle term can be combined. The 2 middle terms can be combined.
What if you wrote by accident 13yx?
It's fine.
It's still the same.
Yeah, just usually we write it in alphabetical order, but it's not like if you write it not in that order, it's going to be wrong. So yeah, it's just typically we write in alphabetical order. Just like I said, typically we go from the biggest power to the smallest power. But again, it doesn't make it wrong. It's just not normally how you would write it. So when you see it somewhere else, it's usually going to be written as xy, but not always. Okay. Any questions on this one before we go on? Okay, so notice we use the distributive property again. We just have to do it twice because there's 2 terms here, right? Okay. All right. Oh, what's going on here? This time we have a binomial times a trinomial. So guess what you think? What do you think we're going to do? Distribute again, right? So we're going to take 2x times 4x squared, and what do we get there?
8x to the third.
Correct. 8x to the 3rd power. Then what should we do?
2 times 7.
2x times the 7x, negative 7x, and what will we get there?
14x
And
to
it's
the
gonna be-
second.
Yep, negative 14x to the 2nd. Make sure you don't lose your negative there. Does that make sense? Okay, then what do you think we should do?
2 times 3.
2x times the 3. And what do we get there?
Plus 6x.
Plus 6x. Is everybody okay so far? Okay. Then where do you think we should go from there?
2 times 4.
Nope.
No, 5 times 4.
The negative 5, we already did the other one. Negative 5 times 4x squared. What does that give us? Negative 20x squared. Right? Because the 5 doesn't have any x's, so we just have the x squared. And then what after that?
Negative 5 times negative 7.
Negative 5 times negative 7. Now be careful here. Negative times negative will give us
Positive.
positive what?
35x.
35x. Okay, and then finally, what do you think our last step is going to be?
Negative 5 times 3.
Negative 5 times 3, which is
Negative 15.
negative 15. Now, I don't know if you realize this, but I only drew 1 arrow that time. Well, I mean, I drew 1 arrow by myself, and you guys told me the rest of the arrows. You see this process just gets repeated? It's not like I'm making magical new things just because there's 3 terms. We still just distribute. Okay. All right, but we do want to combine like terms. So we start with our biggest one. We see an x cubed. Can the x cubed be combined with anything else?
No.
No, there's only one x cubed, so 8x cubed. All right, now I've got a negative 14x squared. Is there any other x squareds that we can combine it with?
Negative 20.
The negative 20. And what do we get when we combine those two?
Negative 34x.
Negative 34x squared. Notice when you are combining like terms by addition, You don't change the variable. They have to be identical to add them, and you leave it identical. All right, now we've got a plus 6x. Do we have anything we can combine with that? 35x. What do we get when we combine those?
41.
Plus 41x. And then finally, we just have a minus 15. We put that at the end because there's nothing else left to combine. And we get our answer, and we went in order. So you can see cubed, squared, first power, and then no x's at all. Descending order. Does that make sense?
Yeah.
At least it seems like you're getting it. So hopefully that's true. At least I'm feeling good about it. I know it seems like you're understanding it. Do we have any questions before we go on? All right. Oh, no.
Oh, no.
It's getting serious. I might have to pull out more colors. So what are we doing this time? Trinomial times trinomial, right? This starts to get a little long. This is about as long as I will ask you to do. So this one does get a little bit long. Let me pull out my colors. Where are my other? Here we go. Well, I'm just excited that you guys seem to be understanding it.
I brought highlighters.
Okay. So what do you guys think we should do first? Distribute. And what are we going to multiply?
2 times 3.
2x squared times 3x squared. And what does that give us?
6x to the 4th.
Correct. 6x to the 4th. Somebody else tell us what we should do next. And give everybody a chance.
2x squared.
Yep. 2x squared times the negative 6x. And what does that give us? Make me stand up here like a statue.
Negative 12x cubed.
Correct. Negative 12x cubed. Perfect. Okay. Then somebody else, what should we do after that? Yep. 2x squared times the 2. And what do we get for that one? Correct. 4x squared. So I have dealt with all of the 2x squareds, right? I've distributed that to everything. So what are we going to do next? 3x. Yep, we're going to do 3x times the 3x squared. And that will give us 9x cubed. Then what? I'll open it back up to everybody because we don't have a very big class, so otherwise I'm not letting anybody talk anymore. So what should we do next?
3x times 6x.
Yep, 3x times the minus 6x. And what does that give us?
Negative 18 squared.
Negative 18x
X.
squared. Correct. And then what else should we do after that? 3x times the 2. And what do we get when we do that?
6x.
Correct. 6x. That'd be
3, 9x to the 3rd.
Yeah, my lines went in the way. I didn't write it down far. I didn't write it down far enough, and then I realized, oh no, what am I going to do here? Okay. So after we've done those two, what are we going to do next, do you think? Multiply the negative 1, right? So negative 1 times 3x gives us what?
Negative 3x.
Negative 3x. Oh, negative 3x squared, sorry. Negative 1 times 3x squared. Then what?
6x.
Negative 1 times the negative 6x. Now, negative 1 times negative 6x will be what?
6x.
Plus 6x. And then finally,
1 times 2.
yeah, negative 1 times 2 gives us
2.
minus 2.
That's
Don't
so
lose the negative.
long.
Don't lose the negative. Okay? Now, once we've got all that, notice we have 9 terms now. We want to start simplifying. Almost always the biggest one is going to be over here on the left. So x to the 4th. Is there anything else that we can combine with the 6x to the 4th? No. saw a shaking of the head, and that was correct. There's nothing else we can combine with the 6x to the 4th. So let's go to the next one. We've got negative 12x cubed. Is there anything else we can combine with that?
9x cubed.
Okay, 9x cubed. Anything else?
Oh,
That's it. So what do we get when we combine those two?
3, negative 3.
Negative 3x cubed. Right? So now let's go with 4x squared. Positive 4x squared. Is there anything else that we can combine with that one?
18x squared.
Okay, negative 18x squared. Anything else?
Yes.
And I think I heard this one too, right? So when we combine all three of those, what will we end up getting?
Negative 7.
Negative 17.
Hold on, I missed something.
Okay, I'm going to write this down, but then we'll wait. Negative 17x squared.
Sorry.
It's okay. Okay. Did you miss a term or an exponent or something?
I missed negative 3x.
Okay.
Me too.
Why?
Because it's all the way to the end.
All right. Now we're going to go with our 6x. And is there anything we can combine with that?
6x.
Another 6x. So we get
12x.
12x. And finally,
We just get
minus
negative
2. And notice, fourth power, third power, second power, first power, no power.
Done.
We're done.
2.
That's so long.
That's
It's
about
okay,
the
but
longest that
it's-
you guys are going to have to do right there. I mean, you could do 5 terms times 5 terms, but I'm not going to make you do that. Because if you know how to do 3 times 3, you know how to do all the rest. Because it's the same thing over and over, right? Multiplying 2 was the same as multiplying 3, wasn't it? So I could give you 4 or 5. It doesn't matter. Are we good? All right. Now, here's where I'm going to give you a little bit of old person advice. Because I've done a lot of these in my life. Now, what's different this time?
You have a 3 outside the
Yeah,
parentheses.
we actually have 3 things we're multiplying together, right? Now, I want to just remind you of something, and whether you realize it or not, I want to remind you of this. If I ask you to multiply 2 times 3 times 5, what would you do?
2 times 3, then whatever
Okay.
you get times 5.
2 times 3 is 6 times 5, right?
Mhm.
And you get 30.
Mhm.
Okay? That makes sense?
Mhm.
Okay? What if, because remember we're multiplying, the order doesn't matter. What if I asked you to multiply these two together first? You'd have 2 times what? 15 and still 30, right?
Mhm.
Okay. What if I asked you to multiply these two together first? What would that be?
10,
10 times 3,
30.
still 30? Remember, with multiplication, the order you multiply in doesn't matter. But it's important to remember, I'm not taking the 2 times the 3 and times the 5. I'm multiplying the 2 times the 3, and you said it exactly. Multiply 2 times 3, get that answer, and multiply it by 5. Right? So this is not a distribution or anything. Okay, so here's my suggestion on these problems up here. This is because I see a lot of people make mistakes when they do these. My suggestion is multiply these two first. Leave the 3 until the end. Okay, so if we multiply these two first, this is exactly what we were just doing for the last several minutes, right? So I'm just going to write the 3 down, and I am going to put parentheses. But then what do we do to multiply these two together? Yep. 2x times x is 2x squared. Then 2x times the 5
10x.
is 10x. Then negative 4 times the x is negative 4x. And then negative 4 times the 5 is
Negative 20.
negative 20. Okay, so we've got parentheses here. we want to, I'll wait till you guys are done writing. Just like always, if there's something inside the parentheses that we can simplify, we should try to do that. Do we see anything that we can simplify?
And -4.
Yeah, we can combine these like terms. So this 3 is still here, and we have 2x squared. This will be plus 6x minus 20.
Mhm.
Does that make sense? Okay. Now, haven't we seen things that look like this? What are we going to do with this 3? Distribute, right? So 3 times 2x cubed, or 2x squared, 6x squared. 3 times 6x, 18x. And then 3 times negative 20, negative 60. And then we're done. The problem that I see students make, or the mistake I see students make, if they don't multiply the 2x minus 4 times the x plus 5 first, is they will take the 3 and distribute to both sets of parentheses, and you can't do that because then you're actually multiplying twice by 3. You're multiplying this one by 3 and then that one also by 3.
Well, the other thing I thought about is like you can't really distribute the 3 because it's not close to the parentheses to the next parentheses, right?
There is a way you can do it. It's just not, again, it's people make a lot of mistakes when they try to do it that way.
Okay.
So it is possible to do it. I'll just tell you, because I don't want to lie and say it's not possible. If you multiply the 3 times the 2x and get 6x, and the 3 times the negative 4 and get negative 12, and then take that answer, 6x minus 12 times x plus 5, then you're fine. Then you'll get the same answer.
Okay.
But the problem is they start multiplying 3's all over the place, and it gets really bad.
Okay.
Because they try to distribute like this, but there's two separate binomials to work with, and so they get messed up. So multiply your binomials first, like we've been doing, and then distribute the 3 at the end.
Okay.
It just will help you
Easier.
avoid mistakes. Okay, does that one make sense? All right, let's see what else we've got hiding on that paper.
We have more surprises?
You guys know what's on the paper already. So actually I'll just tell you, this is actually where we're shifting into section 5-6. And so the special thing about these is that they look almost the same, except for these middle signs are different. I didn't label it. I just put 5-5 and 5-6 together. So, or did you have a question on something else?
Is it number is 2, 4, 7?
I think I skipped several.
Okay.
Is that what you're concerned about? Yeah, I skipped several because doing this is going to be just as much practice on multiplying because we're doing the same thing. So you guys tell me, 2 binomials, what do we have to do? Distribute. So x times x, right? What does that give us?
X2 squared.
X squared.
Yeah.
Then x times 5 gives us 5x. Then a negative 5 times x is and negative 5 times negative 5 times positive 5,
-25.
negative 25. Now this is why they put this in section 5-6, because when we go to combine our like terms, what happens?
They
0.
They cancel out,
yeah,
right?
cancel out.
5x plus negative 5x is 0. Does that make sense?
Mhm.
So that's why they put it in a special section. And I'm like, there's no reason to do that. We'll just keep doing what we've been doing. And it happens to cancel out. So they called that section something about the special multiplication patterns. And this is a special multiplication pattern that makes the middle term cancel out. And so the pattern is anytime your binomials look exactly the same, but the middle signs are different, when you multiply, that middle term will cancel out. That's nothing you have to memorize. Just understand it's okay that that happens. Okay? Are we okay to go on? All right. So notice this is another one where they are exactly the same except for that middle term. So let's see again. What do we do first?
Distribute.
3x times 3x. What does that give us?
9x squared.
9x squared. Very good. Then what?
3 times 7.
3x times negative 7 gives us
21x.
negative 21x.
Oh, that's easy.
Then what?
7 times 3.
7 times 3x gives us
Plus 21.
positive 21x. That's right. And then finally, 7 times negative 7, negative 49. And what happens?
Cancels out.
The middle terms cancel out. Negative, positive. Our final answer, 9x squared minus 49. So like I said, it's okay, and it will happen sometimes. It's okay for terms to cancel out. It'll happen in addition. It happens sometimes with multiplication. Okay, we okay to go on? Right. Now this one, this is where we have to be careful because this looks similar to what we were doing last week or the week before, whenever it was. Because you have an A and you have a B and you have a squared, right?
Mhm.
What's the difference between this and what we had the last couple of weeks?
Symbol.
Adding.
There's an addition in there. This is a binomial. It's not a monomial. Everything we did last week and the week before was all, you didn't know the word yet, but they were all monomials, right? There was no adding or subtracting. When we have this, the 2 can't just apply to both. It won't work. It gives you a wrong answer. So we have to actually think about, what does it mean to square something? If I square 5, what does it mean?
2 times.
Another
5 times 5, right? If I square an x, what does it mean? X times x. You multiply it by itself. So what we have to do is a plus b times a plus b. So do you see we have to use our binomial rules here? I mean, they're not technically called binomial rules, but the rules we used to multiply binomials. So what are we going to do first? Distribute. So what times what?
A times A.
A times a, which is
A squared.
a squared. Then what?
8 times B.
A times b, so that's just ab.
Mhm.
And then what?
B times A.
B times A. And I'm going to go ahead and write that as AB because remember we usually put it in alphabetical order. The order doesn't matter. And then what?
B times B.
B times B. So that is
B squared.
B squared. Now what happens when we try to combine like terms?
Second.
What do we get?
2.
Because this is 1AB and 1AB, so we get 2AB. And then plus B squared. They're not going to cancel out in the middle like they did when they were different signs. And yes, I added those ones in front of the ABs just so that we would, because that's automatically there, right? The ones are automatically there so that and then we can add them together. Questions on that? Because like I said, that's the one that people get mixed up with what we had done before.
Once you do the thing, and then you get rid of the 2.
Yeah,
That's what
because that's what it means is to square it, multiply it by itself.
The grade is already complete for the final test.
The final test? Why are you thinking about the final test? That's like
I've been
a month
thinking-
and a half
I've
away.
been thinking about it too right now.
Oh.
Like,
Because you think like,
But you
Remember
let us
in
know,
all
so there's
this-
no problem.
I never said that.
Hey.
You guys like to say that all the time.
oh.
All right,
we never
so
use the
does
book.
this make sense?
Yeah.
Please let us know.
Oh, wait,
if-
I'm not even thinking about the final test. You shouldn't even be thinking about the final test yet.
Ah,
Do your practice work. That's the important thing.
Oh, I did practice, but in the test it's 20 years.
Okay, so what do we have to do here?
Do
Make the 2 parentheses.
Yep, make the 2 parentheses. Because there's addition involved, we have to multiply it by itself. Okay? Then what do we do?
Distribute.
Distribute. So what?
2 times 2.
2x times 2x is
4x squared.
4x squared. Then what?
Plus 10. X.
Yeah, 2x. Just tell me the answer. 2x times 5, 10x.
Yeah.
Then what?
5 times 2.
5 times 2x is 10x again. And then
5 times 5.
5 times 5, 25. Now notice the difference here. This is again a special pattern because it's a binomial that is squared. So notice in the middle, they're not canceling out this time, but they're still going to be the same, so they'll just add together. So what do we get? 4x squared plus 20x, and then plus 25.
Okay, wait. When you do 20x, it's not to the second?
Nope.
Anymore?
Because
You're adding-
that's only if you're multiplying. If you were multiplying these, it'd be 100x to the second power. But when you're adding, you're just adding like terms. They have to both have x's, so when you write them, they have still an x. It's like you got 10 apples plus 10 apples. You have 20 apples. Does that make sense? Okay. And that's, again, that's another thing that people can get mixed up sometimes. You got to make sure the difference between adding and subtracting and then multiplying. Just practice and you'll be fine.
You'll be fine.
I have confidence.
Just give us 10 chances
I have
to practice.
10 chances.
For each row.
I have confidence
What
in you
about
guys.
5?
All right. So are we good to go on from that one? Okay. Notice this is pretty much the same thing. The only thing that's different is what?
It's
Subtraction, right?
Mhm.
In fact, is this exactly the same as one of the other ones, but I put a minus sign in between?
Mm-mm.
Oh, no, that was a plus and a minus. Okay. All right. So what do you think we have to do?
the same thing, right?
Write it down, right? 3x minus 7y and 3x minus 7y. Okay, they are identical. We're going to multiply them together. So what do we have to do? 3x times 3x is
9x
9x squared. Then what?
3 times 7.
3x times negative 7y will be,
1 xy.
and will be negative 21 xy. And then what?
7 times 3.
Negative 7 times 3x. Negative
Okay,
7y
negative.
times 3x. And that will be
Negative 21
negative 21
yx.
xy again. And again, I'm going to put it in alphabetical order so that we see these kind of match up. And then finally, negative 7y times negative 7y, which gives us
It's a 49.
positive 49 and y squared. Okay, so remember our first step here is that we are multiplying. So we are combining y's and numbers and things. Once we get to here, now we're just adding to combine like terms. Okay, so can we combine anything with our 9x squared? No, and like I said, it's usually just these middle terms. So what do we get here?
Cancel out.
It doesn't cancel.
Oh,
Because
no, it doesn't.
they're
Negative
both negative.
42.
Yep, negative 42 xy, and then plus 49 y squared. Okay, so again, this is, they call it a special pattern. It's in section 5.6 because it's something squared. But notice it's the exact same rules that we've been doing for the last, whatever, 30 minutes. Okay. Any questions on that?
Yeah. Oh. Are you sure?
I do need to talk slower now.
No. Are we done?
We're done. So,
It's all done?
it's all done.
Yay.
So notice 5.5 and 5.6, I combine them into one homework assignment because it's just the same thing, right? You learn how to multiply. Well, you can multiply special cases just the way you multiply all the other normal ones. There's no reason to try and memorize special formulas when you just do what you already know how to do.